And that's why you may think that why 3, 7, all these things are coming. Now, you may think that, okay, this 2K seems very general, very specific case. And this gives an intuition automatically that 2K is probably like we have also the same n here, right? Um, can we get the same thing like doing this again? And you understand the aspect. Can we get the same thing like instead of 2K, can we just do it with n? Because we can take cluster the n to it. This is what I mean by simplifying the problem. When you simplify the problem and did it for 2K, you automatically understand and your mind automatically abstractifies it to make to go you like to help you guide you towards the actual problem out there, that you can also do the same thing for n. So let's do it for n now. So the original equation is 41 by 42 plus 1 by n is a constant, right? Sorry, I wrote it again. 41n plus 42 is equal to 42 n. See, that was the whole equation, right? So let's do the same thing. We will cluster the n together, okay? That's great. So this is coming out that what we're inferring from here, that n should be such a number that is a factor of this, okay? So this right away tells you that n cannot be 5, right? So n is, so we have 3 options, 4 options, 2, 3, 5, and 7, right? We have to understand. So n cannot be a multiple of 5, okay? You can easily understand if n is a multiple of 5, then 5 should divide 42, right? Because if n is a multiple of 5, it will be like this. That means 5 should divide 42, and it is never possible. So 5 doesn't divide n, that is done. Now let's see. Because it is saying that n divides 42 doesn't mean it has always we have to do. It can be 2, 3, or 7 because all of them divides 42, right? So let's see step by step. So what happens if n is equal to 2k, or just n is divisible by 2? If n is equal to 2k, we get 42c minus 41 is equal to 42, is equal to 21. Now what happens from here? Like, can we always say that n divides 2? 2 divides n. Can we always say that? Or this goes the same thing. This is for n 2 divides n. For 3 divides n, it will be, let's say k2, it will be k3 42c minus 41 is equal to 42 by 3, that is 40. For for 7, it will be the same thing, 6, right? So let's take this case. Now let's do the logic from here. 2 divides n means, given this statement, given this, understand this very carefully, logic, because we get confused with this logic. Because this statement is derived from the actual statement, this one. This is the given information. And from that we derive this. So it is saying that given this statements, 2 always divides n. Let's see what the question asks you. It's like maybe, it's like which are always true. You understand. N has to be even. 7 divides n. So you understand. So 2n has to be always even. So how does this statement implies that n is 2 divides n? You see the point. Because n can be 3, right? It also solves the equation. So therefore, you have to prove it, you have to show somehow that n always has to be even. 3 cannot be an option. You see the point where we are stuck right now. So let's take a simple case where n is not even, right? When you this is another way of making it simpler. What do I mean by making it simpler? You solve an easier problem where lesser computations are needed, right? That's why I made it in n equal to n divides 2. Now let's see where n is not even. So what we will do in each of these cases, we will take n equal to 2, we will take n equal to 3, we will take n equal to 7 and see what happens. Where does it break down? Where does the logic break down? You see the point? All of you getting it? So let's take n equal to 2. Why we are doing it? Because the goal is to make it simpler, right? So let's take n equal to 2. If you take n equal to 2, what you get? For n equal to 2, you get 42c minus 41 is equal to 21. For n equal to 3, we get 42c minus 41 is equal to 14. For n equal to 7, we get 42c minus 41 is equal to 6. So can n be 2? If n is 2, then this has a solution. But does this have a solution? That means c is an integer. C should have a solution. That means 21 plus 42 is 62 divided by 42. So it's not. So what does this tell you? Is there a general process? Because we have to follow the same process for all 3, right? It's the same kind of question. Is there a general process that I can devise that solve all the problem together right at the moment. You see the point? Like, and what extra needs to be done? We are putting n equal to 2, n equal to 3, n equal to 7. Now, to understand what extra needs to be done, we have to see what we didn't do before, right? Now, what we didn't do before, when we say n is a multiple of 2, or n is a multiple of 3, when n is a multiple of 7, we are trying to deduce everything from just n. We didn't consider this part. And you see the the breakpoint coming at this aspect that we have to consider also this part of the equation. You see the point? That means this is not true just because c is not coming out to be integer. So we have to also consider the other variable c. So from this, we are understanding that we need not just consider the variable n, we also have to consider the variable c. That's why the examples help. You understand? All of them you will see that c is not coming out to be an integer. That means we have to look into the variable n and see both. So first we have to fix n is divisible by 2 or not, and then you have to fix n is divisible by, like, now we have to also specify that c is an integer. All of you understood the point. You have to see the joint behavior of both of them, not just individual one. So now when we say n is a multiple of n is a factor of this, we should also consider that 42c minus 41 is also a factor of 42. You see the point? We didn't consider this. If it was a factor of 42, then this would have been not the case. We have not considered that yet. So let's now move into the other next part, that both of them are factors. In the previous one, we just considered n is a factor, right? Now we are considering both of them are factors. So n times 42c minus 41 divides is equal to 42, right? So we are considering the fact that 42c minus 41 divides 42 and n divides 42, both. Let's see. So 42c minus 41 divides 42. There are two 42s. They should strike your brain like 242s. What can I do with it? 242s. Okay. That means if 42c minus 41 is divisible is a factor of 42. So what are the factors of 42? It can be 1, 3, 7, 6, 7, 2, 21. Tell me if I'm missing something. And 42 itself. Did I miss something? Probably not. If I miss something, let me know. So that means 42c minus 41 must be among one of them, right? So let's see what it can be. Can it be 3? So 42c minus 41, it can be 1, surely. It can be 2, sure. 2, no. 3, no. 6, no. 7, no. Okay. So how to solve it generally? Let's see. So we want 42c minus 41 times some constant. Now constant is already n. So what we'll do, we'll make it easier now. We want to now, previously we inferred about n, as I have said. Now we'll infer about c. Now what come to my mind is that let's now take the 42 common. Okay, because that is where the game is. So you can do all these cases and you will see only one is the option. But I want to show you the general method, how I'm doing. Okay. So but how did I get this idea to choose the general method? By doing so many options, right? While doing so many options, what you understand is the following. If you say 1, 2, 3, 6, let me do it again for you. When you're doing so many options, you see that 42c minus 41 should be among one of this. But why is it not happening? Let's see, you take 7. So it's turning out that 42 minus 7 is equal to 41. And if you take 7 common here, 6c minus 1 is equal to 41. This can never happen, right? That's exactly the problem, because this is a prime number and 7 is on the other hand side. So you can see it is about the property of the commonness of this factor and 42, not something else. So that's what we will do it here. 42c. So let's break it up because we want to see the aspects of 42. So 42 nc minus 41 is equal to 42. So let's take the 42 now together. Nc minus 1 is equal to 41. Wow, there it is. So you see the fact that 42 can never divide 41, right? 42 can never divide 41, right? So therefore 42 should always divide n. That we have already got. But the interesting part is, understand the interesting part. Let's see what we get from here. 42 has no relationship with this. That means 42 is related to n and this is related to this, or the other way around. But the basic idea is that this and n also doesn't have any common factor because it's nc minus 1. So therefore, the only possibility is nc minus 1 is 41 and 42 is n. Because nc minus 1 has no relationship with n. It's n times a constant minus 1 and n. These two numbers can never have any common factor. Do you see the point? So therefore, c must be equal to 1. But the good thing is that here we have understood, let's forget about this complex strategy. Here we have understood that 42 cannot divide 41, right? So therefore 42 must divide for n that we have got. And for the previous one, we have got n must divide 42. So therefore, if a divides b and b divides a, n must be 42, right? And if we have figured out n, we can figure out c. So therefore, n is equal to 42. And you can see what are the options out there. This is not true, this is true, and this is not true. This is also true. All of you understood how we did the problem step by step? We wouldn't have approached this way. We wouldn't have thought about this. In fact, we solved the problem generally. Like what happened? We were putting n equal to 2, n equal to 3, n equal to 4, n equal to 6. It was not happening. But we took specific cases and understood the pattern and generalized the actual problem and then came back. Wherever we are stuck, we understood the pattern, generalized it. And you see, if we wouldn't have written down this and then we have got this, we wouldn't have got, we should write down all the things that we have observed.